Hello everyone, welcome back to this channel. In this video, you are going to learn how to find the area of what? A parallelogram using what vectors. I have two questions on the board. Okay, so I'm going to look at these two questions. But before we start solving the questions, let's look at the formula that we are going to use. So let's see, I have a parallelogram here. Okay. And then I have vector u here. Okay. And then I have vector v here. Okay, on this side. Okay. And then let's take this side to be the height, and then let's have angle before here, which is the angle between vector u and v. Okay, so in general, we know that the area of a parallelogram is equal to what? The base times what? The height, right? So in this case, this is our base, which is what? Which will be the magnitude of what? Vector v, right? And then this will be what? The height, which is what? H. So for this parallelogram that we have here, our area equal to the base, which is what the magnitude of what? Vector v. Don't forget the magnitude, not just vector v. That's what the height h. Okay, let's just write h here. Okay, but let's take sign of this angle theta here. We're going to have sine theta to be equal to the opposite side, which is what? H over what? The hypotenuse, which is what? The magnitude of what? Vector u. Okay, so we're going to have h to be equal to the magnitude of vector u multiplying what and what theta, right? So we can come and substitute that here. So we're going to have the area to be equal to the magnitude of vector v, okay, multiplying the magnitude of vector u and what theta. Okay, all right. So this is what we're going to have. But from cross product, okay, if I have two vectors, let's say this is vector A and then this is vector B, and then the angle between them is theta. Okay. If I take the cross product of the magnitude of these two vectors, okay, this will be equal to the magnitude of vector A multiplying the magnitude of vector B multiplying what? Sine of what? The angle between what? These two vectors. So I'm going to apply the same thing here. We have vector U and then vector B here. Okay. So applying this formula here, we're going to have the area, okay, this area to be equal to the magnitude of the cross product of vector u and v, okay, and this will be equal to what? The magnitude of vector u multiplying the magnitude of what? Vector v, sine of what? Theta, right? So from here you can see that what? The cross product of the magnitude of vector u and v is equal to the magnitude of vector v multiplying that of vector u and what? Theta, right? And this is what? The area of what? The parallelogram. So you can see that we can use this formula here to find the area, and also you can use what? Get the cross product of what? That's the magnitude of what the cross product of what the two vectors to also what? Find the area of what? The parallelogram. So this is the formula that you are going to be using. Okay. So if you are given the magnitude of the vectors and then you are given the angle, you can use this formula to find them. But if you are given just the vectors, then you can just take the cross product of what? The two vectors, and then you find the magnitude of their cross product. So this is the formula that you are going to be using. So let's go to question 1. So for question A, it says that find the area of the parallelogram in sides A, given as 1i plus 2j plus 3k, and B is given as 4i plus 5j plus 5k. Right, so in this case, our vector u would be A, and then vector v would be what? B, right? So we have vector A to be equal to I plus 2j plus what? 3k. Then have vector B to be equal to 4i plus 5j plus what? 6k. Okay, so now to find the area of what? The parallelogram, you know that you can just find the magnitude of what? The cross product of what? These two vectors, right? Okay, so now let's find the cross product of what? These two vectors. Vector A cross B will be equal to, we are going to form a 3 by 3 matrix here. Okay, so we have I, J, and K. Okay, We're going to have 1, 2, 3, then have 4, 5, and 6. Okay, so let's find the cross product, okay, or the vector product. Okay. So for that, you're going to have, when I cover I, okay, this whole row is gone, and then this column 2 is what's covered. So I'm just going to be left with this part, right? So I'm going to have 2 times 6, right? 2 times 6, right? Minus what? 3 times what? 5. Okay. Then we use square brackets here. Then let's bring our I here. Okay. Minus. Okay. Let's cover J. So this part and this part is gone. So we're going to have 1 multiplying 6 minus 3 multiplying what? 4. Okay. Then J here. Okay. So plus, let's look at K also. So for K, this and this correct. We're going to have 1 times 5 minus what? 2 times what? 4. Okay. Okay. So now let's simplify. Okay, so we are going to have 2 times 6 minus 3 times 5. That gives us a value of what? Minus 3, right? And then we have 1 times 6 minus 3 times 4. That gives us what? Minus 6g. Then you have 1 times 5 minus 2 times 4. That gives us minus what? 3k. Okay, so now this is the cross product of what? A and B. Okay, so now let's find the magnitude. Okay, so the magnitude of the cross product of A and B will give us what? The area. Okay, so now let's find the magnitude. So that will be equal to the square root of. I'm going to ignore the negatives, okay, because they will cancel out anyway. Mary squaring. So I'm going to have 3 squared plus 6 squared plus 3 squared. Okay, so let's see what I'm going to get. We have the square root of 3 squared plus 6 squared plus 3 squared again. So this will give us a value of what? 3 root 6, right? So that would be equal to what? 7.348. So this will be the area. Okay, the unit will go at square units. Okay, so let's take note of that. We're not giving any units for the text. Okay, so now let's look at the second part of the question. Okay, so it says that given points A, B, and C as the adjacent vertices of a parallelogram, find the area of the parallelogram. Okay, so in this case, you see that we're giving the points for the vertices, but we're not giving the vectors straightforward. So it is our goal to find vector U and vector V first. Okay, so let's look at that. Let's take vector U, okay, to be equal to AB. Okay, vector AB, which will be equal to what? Vector OB, okay, minus what? Vector OE, right? And then let's take RV. Let's take V, vector V to be equal to what? Vector AC, right? Which will be what? OC minus what? OE, right? Okay. So now let's find our vector U and vector V. So we're going to have vector U, okay, to be equal to OB, which is what? 4, 5, minus what? OA, which is what? 1, 2. Okay, so this will give us what? This will give us 3, and then 3, 3, right? Okay, so now let's find vector V also. So vector V, we have OC, which is what? 7, 3, minus what? OA, which is what? 1, 2, right? So we're going to have 6 and 1. Okay, so we know that what the area of what the cross product of what vector U and V, right? So let's write our vector U here. For vector U, we have what? 3, 3. And then for vector V, we have what? 6, 1, right? Okay. So now let's look at how you're going to find the cross product. Okay, so for the cross product, you have to write a 3 by 3 matrix, right? So let's see. So vector U cross vector V. Okay, that should be equal to what? So let's have I, J, K here. Okay. And then we have 3, 3. So let's make this 0. We have 6, 1. Let's make this also what? 0. Okay, so let's find the cross product. Okay, so we're going to have, let's start with I. So for I, we're going to have 3 times 0 minus what? 1 multiplied with 0, right? And then minus d for 0 also, we're going to have 3 times 0, okay, minus 6 times what? 0. Okay, and then for q also, we're going to have 3 times 1 minus 6 times 3. Okay, so let's finalize this and see what we're going to do. We're going to get 0i, 0 0, right? And then this also going to have minus 0g. And then we're going to have 6 times 2 give us 18, minus 3 that will give us what? Minus 15, right? So minus what? 15 k, right? So our answer will be what? 15k. That's minus 15k. So the area of what the magnitude of what this value here, right? So the magnitude of vector u cross vector p, actually give us what? The square root of what? 15 squared. I will ignore the negative, right? So let's see. This will give us 15, okay? And of course, the unit will be a squared unit, okay, because of what? The area. So that's how to go about this type of questions. Thank you very much for watching this video. Make sure you like the video and also subscribe to the channel if you haven't.